Okay guys, so in this video we are going to talk about safe proxies, so let's get into it. And basically what we're going to cover is what is a safe proxy, why would we want one, and a basic example pretty much of how it could work. So to give you a bit of a backstory, I recently started reading Build Secure and Reliable Systems. That is a book or a free PDF that you can download at this link over here if you're interested. And the idea behind it is basically that the good people at Google and their SRE engineers, or site reliability engineers, have put together a few ideas on how to scale big systems and make them secure and reliable. Now, something that stuck with me from that book was one of these concepts. Like, I've read the entire book, and one of the things that really stood out to me was this idea that they have of adopting a zero-touch production or zero-touch prod approach to interacting with production environments. Now, to give you just a bit of a mind reference here, so there are multiple ways that you can interact with infrastructure. So some of you may be using Kubernetes, some of you might be using Docker and containers, stuff like that, and some of you are SSHing into live environments, and some people have on-prem solutions. Like, there's tons of different states that could be there's tons of cases which could be your specific situation. And what I think is very interesting is that when you have all these different environments, you have different ways of interacting with these environments, especially in production. Now, how do you guarantee that somebody who's, as an example, using SSH, like that person doesn't by mistake run a really bad command? How do you guarantee that there's not like a malicious user or somebody who has, if you give them, say, your SSH key and they log in and then they can kind of just do whatever they want, right? There's all these different security practices around how to secure up your environments. Now, what the good people at Google in this book, they describe that they have as an approach to dealing with this sort of problem is a so-called safe proxy. And the basic idea is very simple. You have a system and a running application that is responsible for exposing for performing the operation that the developer who wants to perform that operation is going to perform, right? So you have on your local laptop like some CLI with some access token or something like that is connected to this safe proxy. And then you perform a request just as you would on your terminal, but you send that command to the proxy, and then the proxy is responsible for deciding whether or not this is a safe operation. And what's powerful about that is that you can create very complicated security policies for this sort of operation. An example would be, maybe you want to restart the cluster that you're working with. Well, your proxy could check if that's safe, because maybe like right now, for some reason, you shouldn't be able to do that, but you don't know that you're not supposed to be doing that because you didn't check something, like it's just a mistake. And then the proxy can actually just validate that, should we restart the cluster? Well, maybe only if there's no traffic or if we already have some other system that can take care of the traffic, right? Other things could be like, you're by mistake going to delete, I don't know, the root folder of your project in your web application. Well, maybe the proxy should just say, no, you can't do that unless some condition is met. So I made a small example project of how this could work. This is a very simple, basic idea of the structure, but I think it's good enough to kind of showcase the idea. So let's have a look at this server. It's just a small little Express server with the MongoDB instance connected to it, and then we have my application here. And all this is it's a two-parter. It's serving the same need here. So I have an admin interface which is going to be used to approve certain operations, and we're going to touch on that because I thought that was one of those genius things that it seems so simple when you think about it, but you need someone else to tell you about it. And I thought that this was a really cool idea. Now, just to be for completeness' sake, like, this is not This implementation I'm showing you is not from the book. This is just my interpretation of how this could work. So you have some endpoint here for a command, and you basically just send in the command as a query parameter, and then you get the IP of the person who sent the query parameter. I'm just doing this because I don't want to set up a user login and like security and stuff like that. This is just a very simple way for me to collect some information. And I mean, in a real version of this, you would have login credentials and you would have user accounts and like all this stuff. But right now I'm just making do with the IP. And then I create a command request, and a command request is very simply just this thing here. It's just a command, which is a string, and then the IP, and then a creation date. That's it. And then I save that, and then I have a bunch of policies. Now, a policy, for those who may be new to this, is just a rule that states what is okay to do and what's not okay to do. So my policies, if we have a look at that, is in my policies directory here. So I have a file here. And what that's going to do is that it's going to require the file system module, and then it's going to read this file, like this directory here. And then it's just going to bring in all of the files that end with the .json, and then it's going to require those files into the policies here. And then we're just going to export that. So I have two policies here. I have a very simple one called ls. Now, I am in no way saying that you should do it exactly this way, because there's tons of issues with creating a policy this way. I'm just trying to showcase the idea. But in the book, they describe this structure where Google basically has an internal system for this. Like, they have their own policy configuration that they created in-house. And it can be as simple as this. You can create a policy for the ls command. And then you say that the command is ls, and then these are the allowed flags. Now, this is very dangerous, and I'm going to show you why in a moment, why my version of this is super, super dangerous. You should not do this in production. It's just illustrating the idea. And then I have the cat policy that states that, oh, this is the cat command, and that's the name of the policy and the command, and there are no flags. And then it has this Boolean flag called needs approval. And we're going to check that out in just a minute. Cool. So here I'm grabbing my policies, and then I have this function called allow command. And if we go into allow command, it's actually in the utils here. So here, no, was it here? No, it wasn't in there. There it was. I have two utils folders because I am sloppy. Here it is. So as my little description here is going to say, is this allow command is like in my application here, it's like the most important function there is, because this function answers the question, is this a safe command to run? And this is just a toy example. You would make a much more elaborate solution and a lot of unit testing and stuff like that to make this work. But basically, I just take in the command and the policies. I split out the command array, and then I check that you're just using legal characters as an example. And if there are no legal characters, we return undefined. Or if you're not just using legal characters. And then I check the first element of the command array. If that's not equal, if there is no command, we just return undefined again, because then we don't have a command that we can execute. And then I have my flags here, and I just filter out all the flags. I just grab all the flags from the array, basically everything that starts with a dash, because in my simple version we're just supporting one dash. And then I go through all the flags, and then I just check that all the flags are included. And then I return the policy. So this is woefully, I need to say this again, guys. This is just a demo example, a very simple example. The actual implementation of this, if you wanted to do this in production, would have to be a lot more sophisticated than what I'm doing. It's just to get the idea across. So now I have my policies, and I just check if I have a policy, and if I don't have a policy, that I can't find a policy that matches this, that allows this command, well, then I just return and say, hey, this command is not allowed. So if I'll show you an example here. So I have this little CLI here that if we look at my file system here, I have this CLI file, and let's say I want to do foobar. Well, foobar is going to be executed, or it's going to be sent to my little application that's running up here, and then it's going to say command is not allowed foobar, because there is no associated policy. I can't run that command. But if I do this, if I just do something like a string here, ls-all, I can actually get back as you can see here, what just happened was that in my server, it ran the command ls-all directly to my file system. Now in the real application, it would connect to the remote box. I would like give it a URL or something like that. Oh, this environment, can you run that command in that environment? And then once again, the policies would enforce whether or not that's okay, or if I need approval or whatever. And this is the feedback. It's it's no different from, it's literally the same thing. I do ls-al like this, these are equal. They are exactly the same thing. It's just that I'm doing it. One thing I'm doing through my own local computer. The other one is executing through the server. So when I'm sending it to the server can just dictate, is this okay or not? And if the policy needs approval, it's not going to run the command. It's actually going to do something pretty cool. It's going to submit the command for approval. Now, in this very simple example, all that's going to happen is, let's say that I wanted to cat out.js like that. And you remember my policy. My policy said that this needs approval. So now I just got back a response here saying approval request sent for cat utils.js. So this is something that you also describe in the book, that some commands are so dangerous or so risky that they want to make sure that at least one other person or several other people have checked the command and made sure that this is safe to run, so that if it's, as I was saying, like they might be restarting something or removing something really important, you shouldn't be able to do that without making sure that someone else has approved it. And this just reduces the risk so that nobody's making a mistake and that there's no like hacker or attacker who is doing this without your say-so. So if we go back here, you'll see now that it's just storing the approval, and then if all of this passes, it's going to just run this run command function, which is a very silly little, in my little simple example here, all that's going to do is this. It's just going to run out, say that, oh, I'm running this command, and then it's going to call the exec function, which is just execute this in a sub-process. So it runs the command, and then it just returns the callback that I provided with the error message or standard in or standard error, depending on what ever happens, right? So this is just a very simple little example. But let's look at my approval system. So here is my approval page, and this is but ugly, but that's the intention. So here I see that, okay, so here's a new command submitted for me to review, and here I can see that, okay, so this is the command, this is the request, so this is the request that came in from the person who wants to execute this command. And in this, I mean, now I'm just seeing the IP and the command and stuff like that, but here I could have all kinds of information. Oh, they want to run cat utils on this environment, and it's this user, etc., right? And then I see the matching policy. This is the policy that was matched towards this rule, so I can see very clearly that, okay, yeah, this seems to be a straightforward thing. And then I can approve it. I can say, okay, approve. And then here comes the results. And this is now just me getting the cat output from the utils file. This is just what actually was executed when we ran that command. Now, in my simple example here, this is the only place where this is being actually communicated. But, I mean, in our fantasy product here, maybe I'm sitting on the phone with some guy who's going to, or girl who's going to execute this command, and then I just say, yeah, I'm going to approve this, and then I copy paste this and send it to them and say, this is the output of you running that command. And then I just have an index here where I can see that, oh, here are this I haven't approved yet, and here are all the approved commands and who approved it and stuff like that. So I get this overview of, it's like a history log of all the risky or commands basically that needs approval, who approved it, what was the state, and so forth, which makes it very easy to trace all the things that is going on in the production environment. So that's pretty much the whole, like, I mean, we can just look at this. As you can see here, there's nothing magical going on here. Here I actually find I render out the admin page, and here is the approval system that all it does is basically the same thing as when I don't have to have an approval. It's just that now I have approval. So what I want you to take away from this, or at least what I took away from this book, is that if you're serious about a very large infrastructure and you're dealing with the human element, it's a very good idea to try to minimize the amount of human error that is possible to achieve. And usually the more the problem here is that the more freedom you have, the easier it is to mess something up. So if you can narrow that down so that the odds of making something, like creating an error or something like that, goes down, it's actually very convenient. Well, I wouldn't say convenient, but it's a very simple workflow where you have these standard tasks that you want to execute, and you're always guaranteed that there's some safe proxy between you and the actual command, which makes it much less likely that you will break something in production. The downside is, of course, that if you're going to do something very trivial or very simple, you might have added a lot of overhead to your work process. I mean, this is much harder than just SSHing into an environment and just doing everything live. So if you're very secure in that you know what you're doing, maybe this is a bit of hassle for you. But it also gives you that extra layer of security and confidence in that you can always, you're never in a situation where a mistake or some hacker or something like that can do something without your approval, because as you can see here, no other command apart from the ones that I've created a policy for can run. And that is, I think, a very powerful way to control access to your production environments. Have a great day.